Hi everyone, Ravi this side. Welcome to EnggAdda. Today in this video, we are going to discuss about the Stream API, one of the most important feature introduced in Java 8. So let's get started for that, and let me try to discuss about the Stream API in more detail. And later on, we'll practically try to create a project, and there we'll try to see the practical implementation of the Stream API introduced in Java 8. So let's get started. Let me try to go to the next slide and discuss about the Stream API first. So, what is a Stream API? The Stream API in Java is a powerful addition introduced in Java 8 that enables functional style operation on sequence of element. So, make sure you remember this term, functional style operation on sequence of element. So, the Stream API help us in writing the code in functional style on sequence of element like list or sets. So this is what the main agenda of Stream API is. It enables the functional style of coding on sequence of element. It operates on collections of objects, allowing for concise and expressive code to perform the operation like filtering, mapping, sorting, and many more. So Stream API help us in doing the filtering, mapping, sorting, and many more others experiment on the list of objects, on the collection of objects. So this is about the introduction of Stream API. Now let me try to go to the next slide and discuss about the stream. What is a stream? Okay. So the stream is a sequence of element supporting sequential and parallel aggregate operation. Okay. So stream is nothing but it is sequence of elements supporting sequential and parallel aggregate operation. A stream does not store elements. They convey a pipeline of functions to transform a data. So let's say you have a list and you want to convert that list into the stream. Now you have converted that through some methods, okay? But you cannot store the stream how you store the list. You can only convert one list into the stream or transform the stream into the stream, but you cannot store it out. So stream does not store element. They convey a pipeline of functions to transform the data. Now, a stream can be created from the various data sources like collection, arrays, input-output channel, and generators. So, make sure you remember this, that we create the stream out of collections or arrays. So, this is what we are going to discuss in this examples as well. So, what we'll do, we'll try to create a list or let's say arrays of element, and then we'll create or convert that list or arrays into the stream and then perform the stream functions on that, and then we'll try to get the result. So this is about the stream. Now let me try to go to the next slide and discuss about the functional operation in streams. So when you are going to have an interview related to the Java or Spring Boot, and if they are going to ask about the Java 8, they will come to this question of a Stream API. And they will ask you about the functional operation in the stream as well. Like they will ask you about the intermediate operation. What do you mean by intermediate operation? And what do you mean by the terminal operation? So intermediate operation and the terminal operation are called as the functional operation. And we are going to discuss them one by one through the example as well. So first of all, we are going to discuss about the intermediate operation. So these operations can be chained one after another and return a stream. So let me try to tell you that. Let's say you have a list of elements. You converted that list of element into the stream through some function and you get the stream. Now you want to work on that stream and produce the stream itself, not the list or not something else. So those operations that are working on the stream and then again producing the stream. So make sure that the input and output of that function is a stream. So those are called as intermediate operation. Okay. So these operation can be changed one after the another and return a new stream. So example of those elements are filter, map, flat map, sorted, and distinct. These are the example of intermediate operation. They work on the stream and they produce the stream. They take the input out of the stream and then produce the stream. Okay. Now let me try to one by one tell you about the filters, map, flat map, sorted, and distinct methods. So let's say what is filter method is doing. So filter method in this stream filters the element based on the given predicate. So in the previous video, we already have discussed about the predicate, supplier, consumer, and function-functional interfaces. So the filter method takes the predicate in their method argument, and according to that predicate, it will give you the result. So the predicate is, in the predicate, we have to provide some condition, right? The same way in the filter, we have to pass the predicate. In that predicate, we have some condition, and based upon that condition, it will filter out the list of element and then give you a filtered or transformed stream. Okay. So this is about the filter. Now coming to the math, this transform each element using a provided function. So map takes the functional interface, and according to that, it will work and give you the transform element. Now coming to the flat map, it flattens the element after applying a function that returns a stream of each element. Coming to the sorted, this sorts the element of the stream, and distinct, it removes the duplicate out of your stream. So this is about the intermediate function, or you can say intermediate operations. And there are a lot others intermediate operation. You can search it out and you can learn on them. We have discussed this top intermediate operation that are being called or that are being asked into the interviews. Okay, now let me try to go to the next slide and discuss about the terminal operation. So let's say you have a list of element, you converted that list into the stream, you applied the intermediate operation like filter on that and get the stream. Now you want to store those elements in some list. You want to store those stream elements that are being filtered out into some list, or you want to print it out. You want to end the operation. Then the terminal operations or terminal method you have to call on that pipeline. So these operation terminate the stream pipeline and they produce a result or a side effect. So it will give you, it will take the stream as an input and give you some let's say list or some others entity that you can end with, or that you can print out, okay, or that you can store. So this operation terminates the stream pipeline and produces a result or a side effect. That is why they are called as terminal operation. Now these are the example of terminal operations or methods you can say, like for each, collect, reduce, count, any match, all match, none match, and there are many more. These are the main, that is why we have listed out here. Now let me try to explain you one element or one operation at a time. Let's say for each. So this performs an action for each element. So let's say you call this for each method, which is a terminal method, and this for each takes the consumer as an input. Now you want to print out each element out of that stream. Then you can simply pass the system.out.println there through the, let's say, method reference or through lambda expression, and trying to print out those elements. So basically this for each takes the consumer. You have to provide the consumer there. In the consumer, you can either print it out or you can do whatever thing you want to do. So this is the best example that I have told you about the terminal operation for each. Now coming to the next terminal operation, which is collect. In the collect, you can pass, let's say, collection.list to store the filtered element or to store the transformed element into the list. So this reduces element into a collection or a summary. Coming to the reduce, this perform a reduction on the element using the binary operator. Either you can add it out or subtract it out inside the reduce. Coming to the count, this return the count of the element, and the others method like any match, all match, none match, check for the matching element based upon the condition. So these are about the terminal operation, and there are many more. You can learn on them. Now let me try to go to the next slide and discuss about the basic workflow, or you can say the workflow of a stream. How you can create a stream, how you can apply the intermediate operation on it, how you can apply the terminal operation on it. So those things we can, we are going to discuss here. What is the basic overflow, or what is the pipeline of the stream? So first of all, you have to have a list or arrays, or you can say the list of element or collection of element you have. Then on that, you will convert that list of element into the stream. So either you can convert it through the stream method, like how for the collections, let's say you have the list, then you are going to call the stream method on the list to convert that list into the stream. Similarly, for the set, you can call the stream method and convert that set into the stream. Similarly, for the map and for the arrays also. Now, stream generation methods, there are other stream generation methods like stream off, stream iterate, and stream generate. So let's say we are going to discuss about the stream off. So let's say you want to generate a stream of numbers. So you can do is stream.off, and then inside that off you can provide the list of numbers, list of integers there, and that will give you a stream of numbers or stream of integers. Similarly, you can also do the stream of iterate and stream of generate. So this is how you can create the stream. If you have the list, you can directly call the stream method on it. If you don't have the list, you can call this method stream.off and then provide the element inside it, and it will give you a stream. Now let me try to go to the next slide and discuss about the intermediate operations. So after you have created a stream, you can apply these intermediate operations. Like for the filtering, you have to filter, you have to provide you have to call the filter method, and inside the filter method you have to provide the predicate. Similarly, for the mapping, you can call the map, you have to provide the function inside the map. For sorting, you have to call the sorted method, or you can call the different version of the sorted method where you have to provide the comparator. For the distinct, you can directly call the distinct method on the stream. So these are the intermediate operation. Now you have created the stream, you have applied the intermediate operation. Now you have to apply the terminal operation. So make sure that there is you can apply more than one intermediate operation, right? And then you can apply the terminal operation. Like we already have discussed about the for each to perform an action for each element. If you want to collect out, you can call the collect method. Similarly, if you want to reduce, you can call the reduce and count, and there are others as well. So these are the terminal operations that you can apply after the intermediate operations. Now this is about the stream, how you can create a stream and how you can work on the stream pipeline. Now let me try to go to the next slide and discuss about the benefit and use cases of the stream APIs. So they will help you in writing the concise and readable codes. Okay, so stream APIs enables writing compact and expressive code, reducing the boilerplate. Okay, so stream APIs will help you in writing the concise and the readable codes. Now coming to the next point is efficient and the parallel execution. Streams can exploit parallelism when working with a large dataset by transparently partitioning workloads. So this will help you in exploiting the parallelism in your code. Now coming to the third point, which is declarative style. So focuses on describing what to do rather than how to do it, promoting a functional programming style. So this is a benefit and use cases of the stream API. Now let me try to give you one example of the stream API. So here you can see we have the list of numbers, or you can say the list of integers 1 to 10. Now how you can convert that list into the stream? Through the stream method, right? You can call the stream method on this list and it will be converted into the stream. Now you have converted that list into the stream. Now you have to apply the intermediate operations. Like first we are going to apply the filter, which is filtering out the even numbers out of this stream. And then we are applying the second intermediate operation, which is map. And we want to transform that list of or stream of the numbers which are evens and make them double. Okay, and then we are simply applying the terminal operation, which is collect, and then we are collecting that into a list and simply storing that response into the even double numbers and then printing it out. So this is one of the example of the stream APIs, how you can play with the stream APIs. Now let me try to go to the next slide. Okay, so this is about the basic of what I would say a basic introduction of the stream in Java8. Now what we'll do, we'll try to go to the IntelliJ and create a simple application, and there we'll try to replicate this things that we have discussed, and practically we'll try to implement a lot of example related to this stream. There is 2 videos on my channel where I have discussed a lot of questions which are being asked in the interviews related to this stream, and we have solved a lot of problems there. So I will provide the link of those videos in the description as well. You can go and watch it out. Here what we'll do, we'll try to go to the IntelliJ and create a simple application and then try to implement a lot of example of the stream. So let's get started for that.